So, hi guys. I'm Sai. I am an alum of Team 10862. I've been doing CAD and FTC for CAD for 6 years, FTC for like 8 years. So, basically, we're gonna go over how to use a CAD system called Onshape. Onshape is something very close to what we use in the industry, but it's web-based. So, like most people use SolidWorks in the industry, and Onshape is like really, really close to SolidWorks because it was made by the same guy who made SolidWorks, but it's web-based. So we're gonna get started on learning, from scratch. So first, it's just a website. So go to Onshape. Just look up Onshape on Google, and you can just go to the first link. You have to create a student account. I know everybody here is a student, so you click on create a student account and you enter all your email and everything. It's going to ask you for your school level, and a bunch of other things. It's been a while. So just put in the information and just make sure whenever you put your email in, do not use your CCISD or your school emails. Please do not use that because it will log you out or you won't get access back to the account if you use that email after you graduate. And we would like you to keep access to the account after you graduate as well. So please just use your personal email address whenever you're making this account because it will log you out. We have had issues. We had to deal with a bunch of issues about it. So after you do that, you sign in. Hold up. Let me sign in real quick. Should I make it bigger? Yeah. So basically, this is what you're first rated to. If you're making a new account, you're not going to have as many files as me. But this is what you're first rated to. This is where you see your create, which we'll go talk about later, and then your Onshape. You're shared with me, so it's like Google Drive, but like for CAD software. And then I'm gonna go a little in depth on what Onshape. So with Onshape, you can make a team. So if you go to your top right corner and go to click on my account, you can go to teams. You can create a team. So if you have a team with like 16 people, rather than sharing the file over and over again with 16 people, we could just create a team and share the file to the team itself. So you just create the team. Here's an example from our last year where we put all the emails, and every file that is made in that folder or in that team, everybody can see it and everybody can edit it depending on if they have the member role or yeah. So an example is like this year we had four robots, I guess, and we shared all the file with that one specific team, and everybody can access it, I guess. And let me do not disturb. Okay. So first thing we would do is just to make an untitled document. So you go create on the left part, top left, and you click on document, and we can name it, practice. And it will make a document to you. So before we get started, I'm gonna go a little faster, like a little bit fast. So I just recommend try not to follow me. Try to just watch it right now. And when the recording is posted, you guys can go and like pause the recording and then do it yourself, because it's gonna be a little learning curve. Something other. So whenever you first get into a document, you're gonna be greeted to this page. Something we always do as we compete in FTC and we use GoBuilda. We make sure our workplace units are to millimeters. Depending on what your team uses, that's your preference. But to go change it, you got to click on these three drop-down menu right here, and you change workplace units, and you could change it to inches, meters, millimeters, whatever you want. So for now, I'm going to use millimeters because this is primarily an FTC meeting, and most FTC students are going to be using millimeters since they use GoBuilda. So after you get greeted to the screen, you change your first thing. Always change it to millimeters first time, because if you don't change it to millimeters, your document will basically have some issues. So whenever you convert it to millimeters, you're gonna have some weird numbers. So just change it before you get started on the document. So first thing you see is you see front, top, right planes. These are just planes that you could draw on. They come into play whenever you're doing much more like advanced stuff, but since we're using FTC and we're making parts, we should not be like worried about what plane to choose. Whenever you get more in depth into like making much more like custom parts, like something that has like multiple different shapes and stuff, that's when this matters. So first thing you do, we're gonna go over sketching. It's pretty simple. It's like paint, but like in CAD. This is how you make custom parts. I'm gonna be going over sketching. I'm gonna be going over sketches, extrude, revolute, feature scripts, and assembly. These are the 4 things that we're gonna go over in the CAD workshop today. So yeah, let's get started. You click on sketch and you should have the sketch window pop up. I usually just draw on the front plane. Honestly, it really doesn't matter where you draw it, but just pick one and you stick with that whenever you start on the sketch. Whenever you see it, you have a center. So at least before we get started, at least one part of your sketch needs to be touching the origin. Because whenever you draw a square, right, out in the middle of nowhere, the CAD system doesn't know that the square is at a certain point. It basically recognizes it as a free floating entity, and it will cause you some errors whenever you do a bit more like whenever you have multiple complex shapes, it'll cause some errors if you don't have it touch the origin. So always, whenever you start it, make sure that you're always intersecting with the origin. So like, yeah. Something else that I would recommend highly. So you see all these options that you could choose. So the way I do these, I use these is that I use I use my keyboard a lot. So I don't usually go and press the button. I just press, I don't go press this. I have a macro on a keyboard. So as soon as I press L, I'll go on the line, that type of thing. So you could set those in settings and preferences. So set that up. It's just like a game. Whenever you first start a game, you're gonna set your preferences the way you want to control things. So it's basically the same thing. So first of all, you start on your sketch. We're gonna go over a simple line. I don't think it's pretty self-explanatory how to use a line. You can angle it any place you want to. You can make it as long as you want to. Second tool, square. You could start your square in the center, or you could start your square in the corner. And you have the option to be able to choose, and it'll give you a drop-down menu. It really doesn't matter if you use both. It's just a preference thing. So that's a square. A circle, same thing. You got a center point circle, a 3-point circle, which is a little bit different. You would use this for complex shapes, which you won't be doing much of in FTC. I never used this option even any. It's like my first time using this option. So, and then 3-point arcs. These are all something you could play with. Polygons. So you have an option to do as many sides as you want to. I think it gives you an option to change how many sides you want to. We use this a lot to make our axles, our 8mm Rex axles. Everything else here is basic thing. Point. If you want to create a point in like a floating space, this is something that you use. And then construction lines. I'll get to construction lines a little bit later because that's something that I use a lot, but I won't explain it to you without like any references. And then so let's first get started. So we just want a square, right? Let's just build a square. We have a bunch of holes that we want. We want holes right here. Oh, wrong. We want a hole right here. We want a hole right here. We want a hole right here. and we have 4 holes, right? And we were trying to make these holes line straight up, and we're trying to make these holes the same same diameter. So what you do is you click on dimension, which should be one of the options up there. It should be dimension. As you can see, I have to press D on my keyboard, and the dimension key will activate. And then you select your circle, and you go 4 millimeters. Like that's the size of circle I want. You can do that with all the circles, but doing this is kind of annoying, and I'll show you some things in a bit. So I would recommend using these options. These are your favorite options. It should be your favorite options whenever you're using sketching. Coincident, concentric, parallel, tangential, horizontal, vertical, perpendicular, equal, and midpoint. These tools I use basically in every sketch I make, because what happens is that whenever you don't use these tools, you have a mess, right? Like this is a mess, so you can't see what the number is, and you can't see anything, right? It's important that you make it look as clean as possible so other people can understand what you're doing, right? So you're not working on this CAD, alone. You're trying to share it with other teammates. So whenever you CAD something, you got to make it look professional enough so your other teammates can understand. This is a bad example of a CAD. Like if I submitted this to my professor, he would give me a 0, because it's really bad, because he can't see any dimensions. Everything is overlapped and all that stuff. So basically what these tools help you to do is to reduce that, right? So I can make the circle and the circle equal, and the circle, look how the circle is just equally. And if you want to know which circle is equal to each other, you could hover over the circle, and it'll tell you which, and hover over the equal sign, and it'll tell you which circles are equal to each other. And I use this a lot. I'm stressing a lot about it, because it's really an important tool that people use. So the next thing is I want these circles to be straight aligned, straight, right? So what I could do is use the vertical, rather than saying that this to this should be 4 millimeters and this to this should be 4 millimeters. What I could do is I could just say the first one is equal to 4 millimeters, and I could run the vertical sign. I could select the center point of the circle, and it'll be vertical. So you see how the circles are moving now, right? So these are the type of tools that you would want to use. So with 2 dimensions, I've created much cleaner sketch, and I won't have about 8 things on my document. So that's basically it. And then for this, you can't do anything about it. So I'm just gonna do a millimeter. Here to here. So something other thing you guys have noticed is that whenever you have a random circle out in the middle of nowhere, it's blue, right? And you see some of these lines are blue and some of these lines are black. Whenever you see that, whatever you see in black is defined. The software knows that there's a value that exists for that line, for that circle, right? It knows where the circle is on the document. But whenever there's a blue line or a blue, anything blue in a sketch is really, really bad, because whenever you something that's in blue, it can float around because you can drag it around. But something that's in black, you can't do that because it has a defined position. And I highly recommend that whenever you're sketching, to make sure everything in your sketch is black, right? This is a practice that I know a lot of people don't have, because it's really, really hard to for more complicated sketches. You'll see that there's more than a lot of dimensions. So just make sure that your sketches are always defined, and this is not defined. The circle here is not defined. This line here is not defined. I can move this line over and over again. So just make sure it's defined. It's a strong warning, because if I see any of these practices in CAD, I'll be very mad, I guess I would say. So the next thing is, yes, let's define this to this. Let's say 80 millimeters, right? Next thing is we're going to talk about mirror. So mirror is a tool that I kind of use most of the time. So what you do is you select the option. It's going to ask you what line to mirror. So you have to give it something to mirror across, right? So I can select this line, and it's going to say select entities. So I want to mirror this to the other side, this circle to the other side, this circle to the other side. So that's what a mirror is called. So just make sure that whenever you're using mirrors, I'll go over it again. Let's Control Z. So I'll start mirror, and it's going to ask you for a line to mirror. So like, let's say I want to mirror over this line, and it's going to ask you the entities to mirror. And make sure it's a line, right? It needs to be a line. It can be a construction line, or it can be an actual line. Just make sure that it's a line, because it won't let you mirror unless it's not a line. And the next thing, a linear sketch pattern. This tool I use a lot, right? So let's say, let me delete some of these circles. 40 millimeters. Everything is defined. So let's say that I want the circle to be a pattern across of this. So what I could do is I could say that I want to pattern it across. So I wanted 8 millimeters apart, each circle 8 millimeters apart, and I want 8 circles, or let's do 10, right? Yeah, 10 circles on the horizontal side, and then I want a couple more on the vertical side. So it can make circles. Let's do 8, and then whenever you have this problem of like it going on the wrong side, just change the value of your, I don't know which one it is. Is it -8? It should. No. Sorry about that. Just 4, and then 10, and you want it to be 8 millimeters apart. So -8. So because you want to flip the primary axis, and then 8. So I created a sketch of circles that are all defined. And this is something that we use a lot because in FTC, you would like to leave as many holes as possible. And like I use it basically almost in every sketch I make, because it's just easier to do than drawing multiple different circles at one time. And you can do this with circles. You can do it with any entities. That I'm not going to. So like I could pick this entire thing and I could linear sketch pattern it across. I could just do 100 millimeters and you'll have 4 of the same circle, the things. So that's a tool I use a lot. There's also a circular pattern. So instead of instead of it patterning over horizontal and vertical axis, it will be in a circular. So for circular, you select for a circular sketch pattern, you select the entity, and it will pop the circle, and you could change the dimension of the circle. Like you could change. So you want that every 50 degree, this only pattern across 50 degrees, or you want it, go all 360 degrees, something you could do. And it's going to ask you the entities to, go around. So I could click on all different entities, right? And it will project those entities, and you press enter, and you can change the value to like 6 or 7, and you'll see that the circle's made. In this case, like 4 is enough because, or 5, yeah. So that's how a circular sketch pattern works. Basically, that's all about sketching. Bad practices, I've shown you a picture. This is a bad practice to not have this because stuff is not defined. There's a lot of values out in the middle of nowhere. Like you're trying to send this to a machine shop to machine something, right? Whenever a guy sees this sketch, he will hate you because it doesn't make sense at all. The guy cannot see anything he wants to sketch and you're wasting his time to, make the part. It's going to take him more time to figure out what each dimension is. So just make sure that whenever you're doing something, try to use the least amount of dimensions as possible with the least amount of just make it look professional, right? Like this looks more better than if I go ahead and make all these circles and do dimension each circle to be 4 millimeters. So something other thing, I know all of us use Gobuilder. I'm gonna go over a Gobuilder pattern. Gobuilder pattern, it's pretty simple. So you have a center circle that's 14 millimeters long, and then you have 4 circles in the corners. We use the equal to make all of these circles equal. And then we change dimension of 1 circle to 4 millimeters. So the circle in the center is 14, circle on the outside. These need to be horizontal, and these need to be horizontal. And then these 2 needs to be vertical, and these 2 need to be vertical. And then from the center to center, it's going to be 8 millimeters. And then from here to here, it's going to be 16. Oh, sorry, my bad. And then the same thing on the other side, 8. 16. This is the entire. This is the entire Gobuilder pattern. This is a pattern that you can replicate in your builds. Usually, when 10862 builds something, they usually use this pattern just in case if they're missing any holes that they want to align later. So whenever they're making custom parts and like a drivetrain plate, they usually have this pattern that goes across the entire drivetrain plate. And I'll show you an example of a good drivetrain. Next thing, what else? Sketching is pretty self-explanatory. The next thing I want to talk about is extruding. So after you draw your sketch, it's a sketch. It's nothing. It's not thick. Whenever you want to hold something, there's a third dimension to it, which is the z-axis. So something we use a lot after you're done with the sketch is called extrude, and you could select your entity to extrude. So it automatically selects the sketch because Onshape is smart like that, and you could make it however thick you want it. So I want this 10 millimeters, right? And I can make the sketch itself 10 millimeters. You could add, you could remove. So what I want to do is after I made the sketch, I want to remove I want to make a square. I want to remove a square inside. So you add another sketch, you put a square, and make sure you dimension it, right? So I want a 20 by 20, and I can make it equal to equal. Here, 10 millimeters. 10 millimeters, and then you could click on extrude, and you can click on remove, and it will remove. You can remove blind. You can up to next, which is basically next surface, up to face, which is basically you selecting which face that you how far down it needs to go, and then up to part, up to vertex, and through all. You're not going to use as much. But whenever you're doing it blind, try to make sure that your dimensions are properly done. I've had a little bit of issues whenever it comes to making parts. Whenever somebody just does blind and does this all the way, it will cause you problems later. So if you want it to only remove the thickness of your part, so change it to 10 millimeters because that's how thick the part is. And make sure that it's clearly defined. So whenever somebody goes and right clicks and edit, it could see that the depth is 10 millimeters, and you could change that. Any sketch, if you want to go back and edit it, so Onshape is really cool where you could go back to the sketch, you could change. Let's say I want to move this, change this to 20 millimeters, and it will automatically update the pattern into on Onshape. So it's a really cool feature. Other than that, sketching and extrude is pretty self-explanatory. Now I'm going to come over to the what happens after you extrude. Let's say that you want your part to not have sharp edges, right? So this is something that we do a lot in FTC because you can't have any, or it should be done. It's a good practice to be done everywhere. So whenever you have a sharp edge, what we do is called a fillet, and we edge it. So it creates basically a circular face instead of a sharp face. So that's a fillet. You could do that to any corner. So like, let's say I do this corner, and this corner. And then there's something called chamfer, which basically cuts the part into. Sorry, let's click the wrong one. Sorry, there you go. Why is it? Let's just not deal with it. Go to the side. Chamfer is basically cutting it into 45 degrees. This is something that I rarely use, but it's kind of useful whenever you're making parts that you want to slide. It really is a rare thing to use. I don't use chamfer a lot. I use fillet a lot. So just make sure you understand that. Shell is something I would also use. Let's say you want, I can make another sketch, and I'm going to show you how a shell works. Create Part Studio, and then you start a new sketch. Front, how am I doing? Where 10 by 10, extrude 10 millimeters, and then you can click on shell, faces to remove, and it basically shells it. And if you want a shell thickness, you could change the thickness to 1 millimeter. So it basically creates a box, and it will take the inside of the box out. So yeah, and you can't shell everything. I think it won't work like that. So you can only shell up to 5 faces of your square. Other than that, linear sketch pattern, linear pattern and mirror, we talked about it. It's basically the same application, but in 3D, not in a sketch. And all these tools that are on top, you most likely will never use. Other than, I don't know, I've never used these. Something else that I really want to talk about is the measuring tool. On the bottom right corner, there's a measure tool. You can measure the surface area. It gives you a surface area right here. You can change it into change the dimensions, and you could measure how thick the cube is. You could, so basically, let's say you could say I want to measure the difference between this face and this face, and it'll tell you 10 millimeters and stuff like that. This is a really important tool that I use every day. I know I'm saying it a lot, but a lot of tools are something like it becomes a practice, I guess, where I use it over and over again because I want to know the dimension from here to here. There's some times where you forget dimensions, so you could use the measuring tool. It's a really good tool whenever you're using sketching, or even whenever you're doing assembly. So the next thing we want to go over, we talked about extrude. I know I'll talk about feature scripts at the end because feature scripts are a bit peculiar. Next thing we could go is to assembly. So assembly is something that we use to put the robot together, right? So sketches, the part studio is where you make the sketches and where you make the part itself, but assembly is where you interact multiple part studio parts that you make together. So I know so I could bring the part studio part here, and I can bring the square here, right? That type of thing. So these two parts that I made in the part studio, I brought it into this file, this assembly file, because I want to interact these two parts, right? So this is something that we all use to build robots. Let me give you an example. The full robot, sorry, might take a little while to load, but yeah, this is a assembly file where we interact all the parts that we put together. So all the parts are put together properly, and we could see if the parts go together, if we need to change dimensions or anything. Part Studio is basically, let's see, parts of the intake. What's a custom part that we made? I'll take box or something. There you go. So this is a box that we created in a Part Studio, and you can see how many extrudes and sketches that we made. So this is an example of a sketch, and this is an example of an assembly, what we call, where all the sketches that you make are put together. So let's go back to that. I'm going to talk about a couple different mates. I know you guys don't, some of you guys don't have access to the FTC Parts Library, but it's basically a library of parts that you could use it's like online, because we don't want to keep downloading parts and uploading parts into Onshape. So it's already done for us. And I know your own teams are going to be, talking about how to get access to this. It's a really good thing to do because it's basically all the FTC parts that you use. So yeah. So let's go put a piece of channel. And I could say I want a 5-hole channel, and then let's have that, right? So first thing, this is already like an existent part that they've already made, and I just imported it into our document. I did not make this part, but someone else did for me to import in. So you could import parts from multiple documents. So like I could say I want from other documents. I could go home. I could go to a whole different document and import a part from a whole different document. You get what I'm saying? So like I could import like a servo from another document because I'm too lazy to make this part again, that type of thing. So I highly recommend to use this a lot. I use it a lot because I'm too lazy. My professors always said the best CADers are the lazy ones because they CAD all these things with the least amount of effort as possible, which will in turn make people understand the parts better because you don't have to repeat something that you've already done, right? That's basically it. So let's go over mates. After you put your parts in, again, these are the couple different types of mates you use. There's a couple that you use a lot, but there's some that you don't even ever need to use. So first thing, Facimate. Facimate is the mate that you're going to use the most. This is basically, you want this circle to be aligned to this circle, and it will align itself, that type of thing. And you see how these two parts interact. There's this symbol in the right here. It says flip primary axis. You click on that, and it will spin it. It'll put it to the other side. So if I click on it again, it'll go through the part. But if I click on it, Onshape has a very, very weird interface with this. I think they're trying to fix this problem. But basically, whenever you see a part going through another part like this, just flip the primary axis, and the button's right here. And then if you want to change the angle 90 degrees, it's this button, which is, I think it's reorient secondary axis. So it'll flip it to 90 degrees. And then you won't ever use this unless you're trying to make the robot look really cool. So I'm not going to go over it. So offset, if you want this, part to be, floating 2 millimeters in the air, I can just change it. And then, -2, because I want to float in the air, not in the part. It's going to be floating in the air if you could see it from here. So if I change it to -4 millimeters, it will go. For X and Y, it's the same thing, but on the X and Y axis. So like 4 millimeters to the side and 4 millimeters, so like that. So this is something that I would never use. X and Y are something that I personally never use, but a lot of people use it because I have a different. I'm from SolidWorks, so my mates are basically like I use planar mates more than like offsets. But if you want to, have it in the Z-axis, -4 millimeters, that's basically how you do it. Also, you could go back and edit a mate that you already used. So let's say that you don't want these holes to intersect now. You can just remove it and select a different hole on the other side. And yeah, there you go. And it's offset to 4 millimeters. I can just change it to like 8 millimeters to move it up to the other side. Well, let's do like 50. Acting. And then Revolute is a mate that I personally think that it should be stayed away from. It's a good mate to use, but it is for people. It's for things that want to rotate. So let's say I have a shaft that I want to rotate. I'll take you an example. So this is a shaft, and I want the shaft to rotate, or I want this wheel to rotate, and I would use a Revolute mate. You see how the shaft is rotating? For this motion to work, I use a Revolute mate. And the way it works is basically click on Revolute, you click on the circle, and by the way, whenever you use the Revolute, it only works with a circle. It won't work with a square because it's revoluting across, right? And I could click on the circle, and I press enter. So before you do anything, whenever you are running mates, fix something. So right click and unfix, and fix options. So because if you unfix something, you can't move the part. But if you fix something, you see how the Revolute mate works automatically. And this is why a Revolute mate is. I'll just use it to make your robot look cool. Like it really doesn't matter if you use this mate or all. You can just fascinate it. If you know that it's gonna be like a certain spot at a certain angle, just fascinate it so you don't have to worry about it rotating and stuff like that. Slider, it's the same thing as a Revolute, but it basically allows you to slide your circle. You select your two circles, it will do that. So what happens is that you're able to slide this across. So it's basically like, how would you put it? You can slide it on that specific axis, is what I'm saying, right? Next thing is planar, so 2 different planes. So let's say you want this plane of this part and this plane of this part to interact. It's a planar mate, and now the part can't move because we're on a slider mate and planar mate. And if you want to use an interaction between a slider mate and cylindrical mate, is something that's a combination of a Revolute mate and slider mate, is what I was trying to say. So you press the same holes, and you are able to spin this way, and you're able to slide it out. These are the mates that you're going to use most of the time. So this is something that I recommend to practice a bit, because sometimes mates can be a real pain. And I'll show you an example of something that you should not do. Let's see. So as you can see, as soon as I put another fasten mate, it's all red, right? This is a bad thing to do. Do not ever do this, because it will confuse the hell out of whoever is CADing with you. So whenever it's red, make sure you have a reason why it's red. So that, and then other than that, assemblies are pretty much, just putting the robot together. It's going to be a lot of time whenever you're doing assemblies. Like sketches and making parts should not take long, but assemblies do take long because there's like a lot of mates. I know the way we 10862 does theirs. We use about I'll say about 1,000 mates to build this robot specifically. So it's a lot of work. So that's why you have a team. Whenever you're working with a team, you can have students, work on different things at the same time. That's what Onshape is really such a good software, because you can have multiple people work on something. What else? Feature scripts. Let me get back to feature scripts. Feature scripts are something that I use for FTC, but not in industry. It's not an industry practice. Feature scripts are something that I really have trouble wrapping my head around, because this is something that's been programmed by the community. So the FTC community, I'm assuming that everybody here is an FTC or the FRC community. It doesn't matter. You guys, there's some things that you guys don't need to do, like making chain So like whenever you don't want to make, you don't have time to make this, right? Let's see, yeah, you don't have time to make this. So what they did was they made a feature script. They made a program where you could change the value, where you could change the value. So let's say, tooth count 20, 20, and then I could change the like the picture of the chain and stuff. And they made a program so they can generate a chain easily. This is something I rarely use because I'm not into more of aesthetics of the robot. This is something that your teams will most likely do to get like good pictures of the robot. Like if you could see, well, there's actually no chain here. Well, chain's missing. Yell at Emery about that. But basically, it's basically for aesthetics. There's some feature scripts that you do use a lot. Let me go back and show you. Find a document. Yeah. This is an example of a drivetrain that 10862 worked on. And I'll show you a feature script that you guys are most likely going to use outside plate. So vent feature script, let's delete it. So I created a sketch and I want, so whenever you're making a robot, there's some things that you have to do and some things you can't do. Like you want to line your robot as much as possible so there's not as much load on your motors. So what you do is you make holes, or like we cheese the robot, basically. It's what you call it. And we use a feature script after sketch, vent feature script. You select the sketch, and it just automatically vents it for you, rather than you spending your time to draw every single one of these sketch and dimension it. It automatically does it for you. So like whenever I have to do this manually, because I used to do this manually in SolidWorks, it would have taken me about 30-40 minutes just sitting there and drawing this entire sketch, whereas this feature script allowed me to do it in less than 10 seconds. So there are some feature scripts I recommend that you guys use. I will roll out whenever we post a link to this video. I will in the description. We're gonna put the links of all these feature scripts. That's basically, all I got. Right? Am I missing anything? If anybody have any questions, ask me. And this is an example of a robot. So if you want, I could share this robot to see what I did. View. I don't know how to share this, but I'll share it with you guys in the video. So if you have any questions, unmute yourself or speak, or just type it in the chat.
So the one thing that I wanted to add that Sai went over that I think is really important is dimensioning lines and sketches. So he mentioned that if you have a sketch and everything isn't black, so if you have any blue lines, that's bad. And it's not just bad from like the perspective of someone looking at your sketch. It's also really bad because if you look at like a complicated sketch and like in most of what you'll do for FTC, like that's like a decently complicated sketch, what he's showing. But usually sketches are based off of each other. So they will have information that's relative to another sketch. So if one sketch isn't dimensioned, that will throw off the entirety of the rest of the sketch. And basically it could ruin a full a full part that you're trying to make. So having everything dimensioned and having the relative dimension being done well, like Sai said, the best CADers are usually the laziest ones because they do things the most efficiently. Making sure that you're dimensioning things to fixed points, to lines that are going to be not really manipulated that much, it's really important. So I would really emphasizing thinking about having your lines being dimensioned to points that you know aren't going to move. So maybe that's the length and the width, or that's like lines that won't be changed that much. That's really important. That was just one thing I wanted to add.
Yeah, and then something other. Shut up. Okay, I can show you an example. I think I have it. Okay, this is our FRC robot from last year that we competed with. So something I would like to add is we have what's called practice sketch, or an idea sketch, I guess. So whenever we start off, I'm trying to, oh yeah, whenever we try to start off by creating a mechanism, what we do what's called a practice sketch or a test sketch, right? So whenever you get your game first, right, and all that, you're gonna get a game element, but you don't know how it's gonna interact, right? So you know it has to interact with the wheel, and you know how it has to interact with the ground, and you want to plan this out. You want to know where to put your wheels so that the wheel is always touching the ball, that type of thing. This is what an example sketch is. So basically, we made a sketch of the basic structure of the robot, right? And we ran simulations. So we grabbed these balls, the 9.5-inch balls, and we moved it across, and we tried to see if there's any dead space. This is something you guys will do a lot whenever you first start off your building your robot. It's called a plan. It's like a plan sketch. I know engineers have like a different name to it. I keep blanking on it. But this sketch is like one of the most important things, because this sketch is the reason why our indexer is the way it is. Like if you see this, right, all of this parts came out of this sketch, because we wanted, the wheels to be this far apart. We wanted, the wheels to be at a certain spot. And I'm telling you, like I'm reiterating it to you, but that whenever you first start your, CAD for like a complex mechanism, always have a plan sketch that you reference something off of, because it will save a lot of time that you don't have to keep running balls like this. I just did it for fun of it, but you don't got to keep doing it, and you're looking at it in 3 dimensions, right? But whenever you do it in the sketch, you're only looking at it from 2 dimensions. So please have a plan sketch whenever you start off. Whenever you're making a drivetrain sort, I think it's not necessarily worth it. But whenever you're making a mechanism, so like if you're making a shooter, an indexer, or intake, you really want to have this plan sketch, because you want to know how your game element is interacting with the rest of the structure and stuff. That's basically all I have, I guess. Anybody have any questions, concerns? I'm going to put links of the 10862 robot, the 6-wheel drivetrain in the video that we're going to post, and we're going to send it out to the entire Corpus Christi League. So